Hello and welcome along to a little video that's going to help you with those lovely little weather maps, the synoptic weather charts. This one's going to be about depressions. So let's start off with reminding ourselves of what the model of a depression looks like. Here we have our warm front, we have our cold front, and we have our occluded front. And this is the classic model. Let's start with some depressions that look very much like that, because they do exist, at least in some of these simplified weather maps. If you get a weather map like that, it's very easy to see the model of the depression in that actual synoptic weather map. Here's another one that looks slightly different, but is still closely enough to resembling the model itself for you to see the warm front, the cold front, and the occluded front. Here's one final one, very, very simple and very easy to see. Again, the shapes are all slightly different, but they look sufficiently similar to the model for you to be able to spot them. Some of them, however, aren't quite as neat and tidy. The real world very often isn't as neat and tidy, and especially if the synoptic weather chart chooses to show a range of different parts of the weather, not just simplify it down. This one is going to look a little bit more complex, but I'm hoping that you can still see the whole idea behind this. So let's do this. We'll just make these adjustments here and we'll change the opacity. There's the complexity of it there. It's just far too much. Look at all those isobars and all the different fronts and things like that. What we really want to do is in many ways to simplify this down, and this is where you can use the model to go, oh, that's a little bit better. That's neater looking. There's my pink for the occluded front, the red for the warm front, and the blue for the cold front. And your idea really in the exam is when you're faced with that complexity to almost have that kind of overlay on top of it so that you can see the basic layout of the depression. Here's another one that in this case does have those simple fronts, but it does look like it's twisted and distorted. That's because it's twisted round. The depressions will rotate, and as they rotate, they can actually rotate around to something like that. So in the warm sector here, you've actually got southeasterly winds. That's because it has rotated all the way around. So it's not that the model was wrong, it's just that you need to adapt the model sometimes to the way in which reality operates. So let's take a look at a past paper question. Study the information resource 3b. The command phrase here is explain the weather conditions experienced along the west coast of Ireland. So let's simplify the map first of all. Let's see if we can focus on the area that is the west coast of Ireland. Now this is a complex weather map. You can see that there's all sorts of fronts. There is a lot of information here that we need to strip back. So again, we're trying to see if we can see the model, imposing calm and simplicity on top of that. There is the pink of our occluded front, the red of our warm front, and the blue of our cold front. So again, that's really what you need to be practicing as you're looking at these weather maps. Can you simplify that down? Now, which part of the depression is over Ireland at that stage? Well, it's the cold front. It's the cold front. So this is where you can come back into your table where you've learned the different parts and aspects of the weather, and you're singling out that cold front. That's the bit that's relevant here. There's the information that you need. At a cold front, you're going to have cumulonimbus clouds with heavy rain, and the wind speed is going to be gusty. It's going to increase more whenever this comes over. Now, that's it in words. What about a photograph of a cold front approaching? This is a cold front approaching Portrush, and when we talk about heavy rain, when we talk about the intensity of this system and this front coming towards us, look at all of that rain. Look at how much energy must be in a weather system like that, in that front. So we're talking about this heavy rain with cumulonimbus clouds coming over. Have that locked into your head. So let's come back to the map. We're expecting to see here cold front, so cumulonimbus cloud, heavy rain and gusty winds. That's the bit there from the table that you're recalling that's relevant. This is what you're expecting to see. Oh, don't want to do that. This is what you're expecting to see. Now, look at the information in the yellow box in the resource. What specific detail does it give? Have a wee look down there and see what you can extract. How heavy is the rain? How strong are the winds? Right, 100 millimeters of rain. Now, remember from the stuff that we did in biomes. That's a heck of a lot of rain. That's about a month's worth of rain falling in one day on the island of Ireland. That's a lot of rain. 120 kilometers per hour is about 74 miles per hour, which actually, interestingly enough, is the speed at which winds in the tropics in a depression become hurricane force. Now, we don't get hurricanes in the mid-latitudes, they're tropical storms, but those are absolutely hurricane force winds. So when we say heavy rain and increased gusty winds, in this case, 100 millimeters of rain one day, 120 kilometers per hour in hurricane force winds. So here is that turned into text. Ireland is experiencing the cold front of the depression. Now, this tells us that this is a named storm, so I can extract that from the resource. Storm Frank described as an explosive weather bomb. That's the phrase that's used down there in the text, bringing very heavy rain, 100 millimeters in one day. Additionally, a staggering 100 millimeters. Additionally, the very fast winds of 120 kilometers per hour are actually hurricane force winds. So that's a really good description of what's going on. But notice that the command phrase here is explained. So I need to get into my explanation really quickly. This is because the reason for this is due to, however you want to phrase it, a little signpost phrase at the start of your paragraph to let the examiner know what's coming here. This is at the cold front, the cold PM air is undercutting the warmer TM air of the warm sector, causing it to rise, and it rises vigorously. The rising of the air at the cold front is steeper, so the rising of the air is much more vigorous, it's much, much more energetic. Remember what a cold front can look like. Look at that. That is intense, vigorous rising of air. So you want to communicate that. As it rises, it cools and condenses to form cumulonimbus clouds. So we can bring that detail in. As condensation occurs, of course, it's going to release latent heat. And that's going to give the storm even more energy, and that's allowing these huge cumulonimbus clouds to form. These can go right up to the edge of the troposphere. That's a lot of heat energy being released by that latent heat, causing that wonderful, glorious storm. Right, very heavy rain falls from this cloud, sometimes in the form of hail, and the winds here are so strong because the isobars are really close together here. If you take a look at the map, you can see just how tightly packed they are. And to give an understanding of what that means, that gives us a steep pressure gradient. That's how to answer that. You are identifying the depression. You're identifying which part of the depression is relevant here is your cold front. You're extracting the cold front from that table in your head. You're remembering that image, and then you're going in and getting the information from the resource, because you've got to use it as well, and you've got to explain, and that is the answer. Now, there's two types of questions that they can give you in synoptic charts on depressions. The last question, the one we've just looked at, was about one location at one time. So it was the west coast of Ireland whenever the front was sitting over the top of it. The other type of question with synoptic charts is how the weather at a location will change as the depression passes over, which normally takes about 24 hours. So how do you approach that? Well, if it's the one that we've just looked at one location at one time, you read down the column there of the different air conditions or the different weather conditions you're going to get. If it is as the weather changes as the depression passes, then you read across the row principle by principle. So principle number one, air masses explain temperature. Remember reading from right to left. Cool, mild, cold, PM, TM, PM, and you would just go down through those principles by principles going across the row. If you do it row by row, then you're building your explanation in on the way through. So let's take a look at a question that's like that. This is not a past paper question, but it could well be. Using the information in the resource, describe and explain, there's the command phrase here, how the weather, the temperature and the cloud and precipitation will change over the next 24 hours. So it gives you some specific aspects of it here. So notice where we are in London. London is here. So which part of the depression is London in? Well, there's your warm front. There's your cold front. There's your occluded front. So that must be the warm sector. So, in actual fact here, because you're in the warm sector, well, you're going to start halfway across the row, aren't you? London has already experienced that bit of the weather, and it's going to come across from the warm sector, cold front, behind the cold front. So you're going to talk about the weather here is going to be mild, you've got southwesterly winds, then it's going to become cold as you get the northwesterlies coming down here with the polar maritime air mass. Then into the air rises at the fronts, leading to cloud and rain. As air rises, cools, condenses, and forms cloud and precipitation. But again, because you're in the warm sector, you start the warm sector, there'll be no cloud here, no precipitation. As the warm front comes over, cumulonimbus clouds with heavy rain and gusty winds. Then after that, you're into your sunshine and showers. So those are your two different types of questions at one location at one time, and how it will change as the depression passes over. If it's one location at one time, you do the column. If it's how it changes as it passes over, you do the row. And finally, what would a Section C essay look like on this? Describe and explain how the weather changes as the depression passes over. There is a model answer for you to read through. It basically just says what I've just been saying, but it says it in prose. The only thing that I'll add with this that you do need to be careful about in Section B essays, sometimes they will ask you to bring in other information. So a past paper previously said, explain the formation of a depression with relation to the polar front jet stream, and describe and explain how the weather changes as it passes over. So just be careful, as always, to read the question carefully and make sure you address the Pacific, my goodness, what an embarrassing mistake for a geography teacher to make, the specific requirements of the question itself. The next video, we'll take a look at anticyclones and synoptic charts.